who are still coming in, but we are at the top of the hour. Good day, everyone. I'm Rudy Schubert from the IEEE Standards Association, and I would like to welcome you to today's virtual workshop on standardization of private data in energy markets. We have a great lineup of speakers. Just a little bit of background. IEEE and Ellering have been working together on this topic for some time now. We had intended to run a face-to-face workshop last summer in Europe, which clearly didn't happen with the pandemic situation. So we finally decided to put this together as a virtual workshop. And I'd just like to extend my thanks to Ellering, who have been a great partner in helping to pull all this together. I'm just going to go through a few housekeeping details before we get started. If we go to the next slide, please. For all the attendees, the attendee lines are all muted. So this is really a one-way broadcast. However, you will be able to ask questions to the speakers via the Q&A function. You'll see in our Zoom platform that we're using, there are buttons at the bottom for both Q&A and chat. So we would ask you to use the chat only really for technical issues or questions if you run into any issues throughout the webinar. The Q&A is going to be our primary button that we'll be using for questions to the presenters and the panelists later on. And those will be moderated, so we will be tracking those, and the moderator will be asking the questions directly to the presenters on that. So please feel free to use that. If we go to the next slide. Just some quick pictures. We have an excellent lineup of speakers. And at this point, I just want to extend my thanks on behalf of the whole team to all the speakers who agreed to participate today. As we have a lot of content to go through, we're not going to go through everyone's bio during introductions, primarily just introducing people by name and affiliation. However, if you go to the website, which I believe is in the chat box right now, you can go to the website and we have bios for all the speakers, so you can find out more about them through that means as well. And the next slide. I thought there was one other one before that. So, again, use the Q&A for questions as they come in. And at this point, I am going to turn it over to our moderator today. George Root is from Ellering, where he's a digitalization manager. So at this point, I will turn it over to George.
Thanks, Rudy, and welcome everybody. The first telephone line between Europe and North America, the transatlantic number 1, was built in 1956. So that's 64 years ago, and it carried 36 telephone channels. So it is a pleasure to be hosting a conference today with close to 100 participants and live video. So life has gotten a lot better over the last 2 generations. However, there is a long way to go to achieve the Sustainable Development Goals globally. And energy is at the heart of the challenges we are facing. Energy is at the heart of climate change and also the other Sustainable Development Goals. So we are here today to talk about the energy challenge and one aspect of it which is relating to data. Specifically, how can innovators access data to solve energy challenges? It's a story about people and businesses. How can people, homeowners and business owners benefit from those services that need data from these homes and businesses to operate? It's also a story about how to maximize the value from the smart meter rollout that has been happening around the world, and of which there are around 200 million in North America and Europe alone. Today we are here to learn about the lessons from North America and Europe, and we will hear from innovators, utilities, governments, academics, special interest groups. So it will be an opportunity to learn both ways. Data access is a hot topic right now in Europe, as the European Commission, which is sort of the ministry for Europe, they are drafting the law for how should data be interoperable around Europe, how should data sharing from smart meters be operated. There, of course, is over a decade of experience in North America in this topic. So we, in the form of Green Button Alliance, who are all represented here today. Also, I'd like to thank from my side IEEE, who's well known as a global association of professionals with over 420,000 members. And there's, among the many things they do is standardization. So potentially there's some scope for standardization in the data access area. And Elering, as the national grid of Estonia, the transmission system operator for power and gas, is also operating a smart meter data warehouse. As Estonia, being a small Nordic country, North Europe, with 100% smart meter rollout, we see ourselves often as pioneers, and we have been pushing for interoperability on a European scale over the last 3 years. So it is with great pleasure that we are here today, gathered to learn about North America and also to share what's happening in Europe so that we can move faster together towards doing our bit to help the Sustainable Development Goals and helping fight climate change. So with that, I would like to hand over the floor to Julia Serra from DG Energy, the European Commission for Energy. Thank you.
Yeah, good afternoon, everyone. And indeed, thank you. Thank you for inviting me. And indeed, an introduction straight to the point. This event, despite teleworking times and despite a pandemic, a COVID, can really bring us together. We can really cover the distance here. Today, I would like to provide you with an overview on what is happening at European level, and also actually welcoming your contribution and your comments. I really look forward for this discussion to learn and to better understand what are the needs and what are the actions that are to be concretely implemented. To meet the European Green Deal ambitions, we need indeed to decide a modern European energy system that relies on clean energy technologies and also contribute in making Europe fit for the digital age in a way that can benefit our citizens, our businesses, and the environment. This twin digital and energy transition calls for a better functioning, smart, integrated, and interconnected energy system where new business models can easily emerge in a fast-changing market. The transition towards climate neutrality has then to rely on a smarter and more flexible system, building on consumers' engagement, increased interconnectivity, improved energy storage deployed on a large scale, demand-side response, and management through digitalization. Thus, we need to implement even more digital solutions. Digitalization has in fact the potential to accelerate even more the transition, is indeed the enabler to achieve our twin goals of a European Union that is sustainable, a European Union that is green and is digital, especially now during this recovery period time. At the same time, we know that digitalization brings new challenges specific for the energy sectors, in particular in terms of cybersecurity. Energy is the most critical infrastructure that other critical infrastructures depend upon. And with more and more smart devices connected to the energy grid, security of devices is extremely important for energy security, and especially if we really want to engage with consumers, with end users, with citizens, as if we really want to enable this market that is integrated and interconnected. With that said, I would say facilitating interoperability on energy data, platforms, and services, enhancing the uptake of digital technologies and digital solutions in the energy sector, empowering citizens, ensuring cybersecurity, and reducing the energy consumption of ICT are key areas that we need to focus on to digitalize the energy system, to facilitate the energy system integration, while creating a positive experience for the end users. In this context, it's important to flag that we are currently working on the digitalization of energy action plan that has been proposed in the energy system integration strategy adopted last year as one of the key actions to accelerate the implementation of digital solutions. The action plan on digitalization of energy will build on the common European energy data space This has been one of the 9 common European data space described in the communication on European strategy data that we just published recently, 19th of February. The aim of this common European energy data space will be to promote a stronger availability and cross-sector sharing of data in a customer-centric, secure, and transparent manner. And this would indeed facilitate innovative solutions and will support the decarbonization of the energy system. And this is exactly what we want to support with our action plan. The action plan wants to contribute to the implementation of the clean energy package and be also in line with the communication on Europe's digital decade. In this way, we are really working on this action plan to contribute to the energy policy objective that we have set at European level by supporting the development of a sustainable, cybersecure, transparent, and competitive market for digital energy services. We need to ensure data privacy, and we need also to support and drive investments in digital energy infrastructure. We not only need to foster innovation, to mobilize research, but we also need to actively push for the implementation of more major digital technologies that we already have available. The action plan also aims at focusing and providing solutions on how to overcome the challenges that are indeed related to the energy sector and indeed related to cybersecurity, data access governance, data protection, data privacy, the growing consumption of the IT sector, while of course creating a market, a framework where actually end users and consumers can actively play a role. I will go more in details later on this action plan. The timing of its adoption is still to be defined, but just to let you know, we are currently working on it, and we really welcome feedback. We are trying to engage more and more with member states and with stakeholders, because this action plan will concretely be a list of actions for each of the area that we will focus on how to make it possible, how to support the development of such market, how to support the development of a data-driven energy services market. As I mentioned, we have different areas that we need to focus on. Of course, we need to empower citizens. It means that we need to develop tools to support citizen engagement in the energy market. We need to ensure that the design of a data-driven energy services market has consumers' benefits and their rights and its core. We need to develop and implement reskilling and upskilling pathways and digital energy literacy. And we also need to pay attention to address different concerns that are related to energy poverty issues. We need to enhance even more the uptake of digital technologies in the energy sector. So going back to the need of mobilized research to foster innovation, but also to actively push for the deployment of more mature technologies. We need to accelerate such development, implementation, and upscaling of digital solutions. Plenty of solutions already have been developed through different EU funding programs like Horizon 2020. As an example, between 2018 and 2020, the EU has invested more than 100 million euro in support of research and innovation projects for testing, development, and application of different IT innovation in the energy sector, big data, cybersecurity. Now the challenges that we see, indeed, the 2021 will be the year of implementation. 2020 was for the European Commission the year of sitting tight, setting strategies and planning actions, but this has to be the year of implementing our action and indeed to have an impact for our economy, our citizen, our business, and the energy sector. So it's now the time of making even more use of complementarities between the different instruments that we have available. And in this specific context, I'm thinking about Horizon Europe and its partnership, the Connecting Europe facility, the Digital Europe program. We need to support innovation. We need to scale up technology. The Digital Europe program is, as an example, a program focused on building the strategic digital capacity of EU and facilitating the wide deployment of digital solutions. We have also, of course, Horizon Europe and its partnership for research and innovation. We have the Connecting Europe facility to further implement and invest on digital infrastructure. We need to drive investment in a combined and consolidated way. We need to create and consolidate synergies because we need to have a final goal to reach, and we all need to work towards the achievement of a common goal. Another key area we need to focus on is addressing the energy consumption of ICT. We know that digitalization is leading to growth in the energy consumption that is needed for data processing, for communication, for distributed devices, software, and so on. Ensuring synergies between digital and climate actions requires to manage this energy demand and to make it climate neutral. It means that we need to apply what we call the energy efficiency first principle. We need energy efficient solutions, and we need to use renewables at all stages of a digitalized energy value chain. So what is the challenge that comes out from here? We need to drive and to stimulate further investment in this specific direction. So we need to work and we need to set up actions in line with our European digital strategy, with our circular economy action plan. So on one hand, we need to make sure that the IT sectors use energy very efficiently. On the other hand, we need to use the energy demand of the IT sector to drive investments in renewables, and we need to promote further investment. Here, an example would be indeed to stimulate investment through long-term power purchase agreements, such as some that are already having their impact on the energy market. Another area we need to focus on, another challenge that we need to face is ensuring cybersecurity. With an increasing digitalized energy system and more home appliances digitally connected, ensuring cybersecurity and at the same time, of course, guaranteeing our citizen privacy have become of a paramount importance, I would say, is a precondition if we really want to develop a data-driven energy services market. Cyber attacks are considered amongst the top priority risks to address, together with other forms of different attacks. And to secure the energy sector, we need not only to address specific challenges related to cybersecurity, but all the challenges that are related to the specificity of the energy sector itself. So here I'm talking about real-time requirements, cascading effects, mix of legacy technologies with state-of-the-art technologies. And this will be done at European level through the forthcoming network code on cybersecurity under the electricity regulation. Once again, here the timing is not set yet. We are now acting and planning in waves. So we will have more details on the timeline of all the initiatives at a later stage, but we know that actually this is going to happen. As an example, in December, the Commission adopted a package on cybersecurity and critical infrastructure. But of course, we really need to focus to the energy sector related challenges. And last but not least, going back to the reason behind our being here today, what does it mean for us, the twin transition? The digitalization of the energy sector will have to support and enable the development of a data-driven energy services market, able to value flexibility of the energy system, demand response, smart charging, and better services to consumers. So once again, all these areas that I touched upon have something in common: the need of data, the importance of data for the energy system. Easy data access and data exchange will be indeed necessary to create a competitive market for energy services that value flexibility and thereby help the integration of renewables into the grid. And once again, let me go back to the scope of the action plan. One of the areas of the action plan on digitalization of energy will be find a way to support the development of a European digital data infrastructure. Here, the aim is indeed to facilitate data exchange at appliance level and among different players along the entire energy value chain. And once again, this is very much in line with the recently adopted European strategy for data and its common European energy data space. So what is the link between these two activities, and how do we intend to move forward? The European data strategy is a framework for, indeed, European data, implementing common data space. Within the strategy, we have listed 9 data space covering like a specific sector, and energy is, of course, one of them. At the same time, we need to cover and to address and to find solutions for specific sectors like the energy one. So what do we intend to do? We need to explore what are the different solutions for setting up and running a common data space for energy in the respective research and development calls under Horizon Europe. We have these kind of measures that, in combination with the implementation of the clean energy package, so regarding specifically the data-related provisions, can give a good foundations towards, indeed, this seamless data flow within the energy domain. The importance of data is also extremely highlighted in the clean energy package. The clean energy package explicitly states that irrespectively of the data management model used, member states must put in place transparent, non-discriminatory rules for access to data. They need to ensure cybersecurity and data protection, and of course, the institution and as the European Commission, we need to provide our support. And with the help of experts, we are currently working on developing a network code on cybersecurity, as I mentioned before, and implementing acts on data interoperability. So what does it mean? That actually data exchange, data access, interoperability of data are really at the core of our activities to favor like a digitalized energy system. We can create new possibilities and services in modeling, planning, and monitoring that can help different areas, such as energy system innovation for network operators, energy performance assessments, renovation strategies, definition and implementation of sustainable energy and climate action plans by local and regional authorities. This means that we really need to work closely with member states, but most of all with the digitalized and now digitalized energy value chain players, meaning at one point we will have to create and consolidate synergies between the digital value chain and the energy value chain to make it happen. And here, of course, the question is that we do not know yet what are these new business models that will emerge, but we know that we need to get ready. We need to enable such a market. We need to allow the different players to be able to compete fairly, and we need end users and customers and citizens to play an active role. The question is, of course, how do we want to do this? And once again, we are really pushing in making an even more use of the complementarities and the synergies of a combination of instruments. We know that the Recovery Fund and the Next Generation EU offers a great opportunities. In the recovery funds of Next Generation EU, we have 37% to be spent on climate, 20% to be spent on digital, and we also want to ensure a proper governance of interoperability standards and data exchange infrastructure. We will implement rules under the Clean Energy for All Europeans package, under Horizon Europe, the Connecting Europe facility. And what also we would like to do is indeed to try to see if it works and try to propose and to work on the digitalization governance system for the energy sector. We really want to increase the trust in data sharing, strengthen mechanisms to increase data availability, and overcoming technical obstacles. Of course, what does it mean? We have all these activities now planned going on that we really aim at implementing in waves. But of course, we know that we should involve governments, regulators, stakeholders, address technical and organizational aspects of data exchange, finding a way to monitor progress, most of all, collecting indeed data to better understand what are the kind of data we need to collect and we need to exchange. So there are indeed a lot of synergies, a lot of challenges, there are a lot of activities going on, and this is also the main reason why we are now working on this digitalization of energy action plan. we see this action plan really kind of bringing everything together, exploiting the potential of the tools that we already have available, creating and consolidating synergies, working on complementarities between different instruments, and it will also help us in better understanding what is still missing. So I think that also the discussion we will have today will help us in better understanding, okay, what are the key actions for each area that we would like to cover, for which data access and data exchange and interoperability will play a key role, what are the actions that we need to implement. And I think so that the discussion we will have today will really contribute to this purpose. So I not only look forward for listening to the other speakers, to the question of the audience, but also, indeed, I really hope that we can have a follow-up discussion on what needs to happen next. And yeah, this is. I hope that it has not been too long or too many information in too short time.
Thank you, Julia. There was once a joke in The Economist which said that what does Europe export? If North America, US exports technology, other perhaps manufacture good, what does Europe export? And the joke is that we export regulation. That the rest of the world is using some version of GDPR, and maybe the same with energy regulations. We have a few more minutes before the speaker, so I take the opportunity to ask from you that what do you see perhaps the immediate challenges to having regulation about data in Europe, the biggest challenges that you see right now?
Indeed, is as I mentioned before, one of the biggest challenges that we are currently facing is indeed how do we enable the creation of this European data sharing infrastructure for new energy services. We really need to better understand how do we do that, because of course there is a lot of intention. We know that there is a need. On the other hand, we know that actually we need to establish a dialogue with member states with particular interest. At the same time, we also need to ensure cybersecurity. We need to ensure that consumers and end users are actively engaged. So is indeed the creation of such a market. And one side is a competitive market, but has also to make it possible for new business models to compare and play into this market is of course a challenge, because we are still trying to better defining, okay, how this market looks like. What are the enabling factors? What are the barriers? What are the barriers that we need to shut down? At the same time, keeping in mind the constraints and the requirements, all the challenges that digitalization bring with it. So I think that this first point on a data sharing infrastructure, the enabling factors behind the data sharing infrastructures is now one of the main challenges we are focusing on also within the GNR. We are collaborating across different units to really better understand how do we make it happen. How does this market has to look like? What should we focus on? What can we do from a regulatory perspective? So leaving some freedom on one side, respecting requirements, protecting our citizens and end users, at the same time respecting member states' particular interest and acting as a European Union. So I think that, yeah, we are very much, we are discussing quite a lot internally on how to do that. And of course, yeah, any kind of input is more than welcome here.
A good balancing act and a great opportunity to learn from the North American approach. We will hear, thank you, Julia, for your excellent overview of what's happening in Europe. And I will hand the floor next to Dr. David Wallman to talk about the background of the Green Button initiative. So Here you go, David.
Hello, everyone. Thank you for the invitation. My name is David Woolman, and I will describe the motivation and development of the Green Button Initiative. And then I'll pass the baton to Jeremy Roberts of the Green Button Alliance, who will continue the story with what's happening currently in North America. Next slide, please. My organization, NIST, is a federal agency. We're a non-regulatory agency in the United States Department of Commerce with a mission of advancing measurement science, standards, and technology. Next slide, please. We cover a broad range of technical areas, and our program, Smart Grid and Cyber Physical Systems, covers the units indicated there. Next slide, please. Here's a brief outline of my talk. Next slide, please. Many people know NIST through our best practices and guidance documents, including frameworks. Frameworks are some of the best practices, an understanding of a subject, working with stakeholders, understanding what are the key points of an area. So for example, in cybersecurity, we have a very well-known NIST cybersecurity framework, and we've recently issued a privacy framework. The one I'm going to focus on today is the NIST Smart Grid Interoperability Framework, and our Green Button work came out of this effort, sparked by legislation in the US going back several years, but it gave NIST the responsibility to work with industry and others to develop a framework on smart grid interoperability. Next slide, please. We've produced several of these frameworks, and the activities that underlie these frameworks have ranged from working with detailed devices such as phaser measurement units to situations like energy usage information. Our first framework back in 2010, and even the work earlier, identified energy usage information as a very important element of what needs to happen to support our energy services. And this work has gone all the way up to the present. Last week, we issued our most recent NIST framework, release 4.0. Next slide, please. And within that, we give a case study on creating value through data interoperability, which calls out some of the Green Button-based benefits. Next slide, please. So when we are identifying the need and helping to create standards and the technology foundation, there's many different steps that you want to go through. You want to understand what the need is. In this case, following Julia, there's a real need to empower customers, and this continues on through today. And energy usage information is the core of being able to do that. It's the information you need to make good decisions. Another thing you need to do is you need to identify the landscape. You need to work with different stakeholders and standards development organizations, such as IEEE. In this case, when we first started, we knew that there was some different standards and we needed a unifying voice within that. So the goal was to create an energy usage information model that was commonly available, including not just electricity, but also extending into gas and water, because many of the same conditions occur in those infrastructures as well. And then you want to make good progress, and we worked with stakeholders. We made some compromises that kind of focused in on what the energy usage information would be versus what other stakeholders needed. Next slide, please. And in this work, we picked a particular standards development organization, the North American Energy Standards Board, but we pulled in different stakeholders who had different perspectives. There was the utilities, which were quite comfortable with the IEC and its common information model. So that was an important piece. But there's also the building owners and facility managers. And they had worked over time to develop up information models, describing how those systems work. And what we needed to do was look at the interactions with the electric grid, the smart grid. And we did this work in order to kind of call out what was common among them. If you go to the next slide, please, you'll see here that there are all sorts of different aspects of energy usage information that we wanted to address. One thing that I do want to mention, Julia had mentioned the importance of privacy in this work. And very early on, we had recognized the need to make sure that we are addressing privacy issues. So we engaged with privacy stakeholders and made sure that they were part of the process. And in doing so, we made sure that the energy usage information did not include information on the customers, but that was kept separate. It's still very important, but it was kept separate. Next slide, please. We also worked on modeling, UML-based models to understand the different dimensions of energy usage information and then be able to develop XML schemas. So this is that technology piece to it. Next slide, please. And we were able to, for example, have a nice XML representation, and you can do various things like a web presentation, etc. Next slide, please. So at this stage, we've developed some of the foundation. We developed a core energy usage information model. We went on to develop an energy services provider interface, which got to the communication of this information, including to third parties. But then you start thinking about, how do you put this into practice? The implementation issues. You're going to have all sorts of things you're going to need to address. The customer interest, what is the business value, the business propositions? What are the policies that govern this? What are the mandates that might be resulting from this, etc. Next slide, please. And so if you think about smart grid data and other data more holistically, there is an interest from government, but government also needs to know that this ecosystem has many different players in it and different stakeholders and different motivations. So the graph that I show on the right side is a way to remind of where some of the factors are. So when you're generating data, there's an important coupling to your physical infrastructure, the smart meters that were mentioned. And in the utility space, this is owned and operated by investor-owned utilities and other types of utilities. So by nature, this is not necessarily within the government control space. This is private industry. So you're going to need to make sure that you're interfacing closely with private industry as you're developing things. As you talk about moving and storing data and using the data, there is a very strong policy component to this. So this is where governments often get most involved. I list a couple roles here on the left. The federal government, is a good convener, a motivator, a first user. We provide funding. We often provide the impetus for things. But we work very closely with state governments who have jurisdiction over the energy distribution systems at a state level, and also their state energy policies, in addition to a national energy policy. But very important to this is that the government is only one player in this ecosystem. If you look at kind of creating programs, you have both a top-down and bottom-up perspective. So far, I've described a bottom-up perspective. But there's a whole different range of steps that you take in order to make something become real and provide value to customers. And one of the important lessons that we've learned over time is the great importance of having industry leadership in this in order to make sure that you're having long-term impact. That's a way to make sure that governments will, new administrations will come and go, but with industry leadership, that's a good way to make sure that things produce value. Next slide, please. So going back to this, what is the next step? We had a really good situation with the green button standards. We had a good technical foundation, and then we wanted to work on making this be a program that would positively impact customers. Next slide, please. And what we ended up doing was there was a green button initiative that was created. And I'll go through some of the components of it. It's a very long story. I'll pull out some highlights of it. But through this program, we were able to address green button, download my data, getting the information into the hands of the consumers who could then choose to do what they wanted with it. But also green button, connect my data, which was making it easy for a customer to direct, for example, their utility or whoever it is that's holding the data to easily transmit that data to a third party of their choice who may be able to provide some value-added services. So there's a whole range of things that happen in this, and you also see that there's an important role for standards and testing and certification within this. Next slide, please. One of the nice things about working with the White House is that we had the ability to pull together different agencies. So NIST and the Department of Energy, along with OSTP in the US, led this effort. We aligned it with the government priorities and initiatives. Open data and my data at the time were all about getting information into the hands of consumers to help them. But there's also other things, such as making sure that we were respecting privacy. There was the Smart Grid initiative. And all of these kinds of things were quite important, and having the benefit of a White House leader such as Anish Chopra be able to help call everyone to arms to kind of lead this program, was a great benefit that we had. Next slide, please. And we branded this as White House inspired but industry led, because industry is very important to this, getting the utilities voluntarily on board, with the California utilities as some of the first implementers. But then with different folks, including in Canada, we were able to broaden the base of deployments. And one of the things then that looks at is, you may have data from different jurisdictions. How do you make sure that there's interoperability with the data, that the data is same between all of these different areas? Next slide, please. So I'll just say a few things here. There was a whole lot of work that went into building this ecosystem. But one of the things you need to do is you need active engagement with both the partners that are interested, but also skeptics. So this was a very important step for us to make sure that we understood the concerns of the utilities and others, but also understood the needs of the marketplace, the tech innovators, the startups. What they needed was, in essence, an ecosystem in which customers would gather their data and they could compete to make good use of that data. But they wanted to have some scaling, and they wanted to have some interoperable data so that they weren't dealing with different data every time that they worked with a different jurisdiction. We also did a lot of work with, like the websites, the branding, the tech tools, such as test harnesses to make sure that the data was as interoperable as it could be, testing and certification, working with DOE on privacy issues, et cetera. But one of the other things that was also useful was the power of government. At the time, with the administration being very interested in this topic, we were able to work with Department of Energy and the Environmental Protection Agency, the General Services Administration, use executive orders to kind of point to Green Button as an important program for them. So all those kinds of things go into setting up a good initiative, but at the same time, you need to set the foundation and really bring in industry and find a way to help them take up the leadership of it. So it's kind of like you needed to get started running, but then you also needed all of your relay team members to be able to come up to speed. Next slide, please. And this is where we worked with industry to help establish a Green Button Alliance, a nonprofit organization that was launched in 2015. NIST is, while we are passing the baton to industry, this isn't a passing and going away. This is a team approach where the poll runner we pass off to, but then we're there cheering and helping and supporting as best we can, because this is a very important issue. Energy usage information is key to empowering consumers. So NIST, for example, has continued to engage. I represent NIST as an ex officio board position on Green Button Alliance, and we have a small cooperative agreement to help support this work as well. Next slide, please. So with that, I will conclude and then be able to turn things over to Jeremy Roberts of the Green Button Alliance in the next talk. Thank you very much.
Thank you, David. Before handing over to Jeremy, I would like to remind the audience that you can ask questions in the Q&A. So feel free to type your questions if you'd like to ask anything, and we will make sure that the questions are answered. You'll find the Q&A button under the slides. Perhaps also one more question, David, to you before handing over. What would you say were the key factors for success? You mentioned that you had industry engagement, industry-led. What do you attribute the success of the rollout to? What's the most important lesson, perhaps, that Europe should learn from the initiative as it was launched?
I think there are a couple things. people understood the importance of this subject. They knew that in order to influence consumers' behavior, they needed to support them with information. So there was a really good value proposition from a societal point of view. But at the same time, the utilities also wanted to support their customers. They had always been, willing to do, like, for example, spreadsheets with information on usage. This let them work within a national initiative to provide something that would be commonly available and useful. But they also were able to make sure that they were in the good graces of their state regulators, because they were very careful about preserving privacy and making sure that security was in place. So I think there was, like, a good value proposition for the customers. I think we still need to work on the value proposition for the industry and economics ecosystem. And then just having the support of various folks willing to contribute and pulling together all of the different capabilities of government and industry working together, I think, was part of what made it a success.
We have a question in the Q&A to you as well. Are there key performance indicators, KPIs, for Green Button? And if so, can we share them? So how do you measure success?
Jeremy will go over the take-up of Green Button, and also I believe some of the panelists will describe that. So that is a key performance indicator. How available is the data across the US and in Canada? What states have chosen to implement or ask their utilities to implement data sharing, including with Green Button. And then also a longer term indicator would be the ability of a customer to get the information and then make informed decisions about their investments. So, ideally, it's a little bit harder to measure, but you would want the availability of Green Button data to be able to support investments in improvements that customers would see.
Great answer. And we have one more question just arrived. So I believe this will be the final question to you, David, and then we'll hand over to Jeremy. What is does the Green Button specification support data ingestion and storage for CT/PT meters? I must admit, I don't know what those are, but do you know what, if you know what CT/PT meters are, then you can answer that question. Does the specification support them?
So I believe that they're referring to a broader class of measuring devices in the grid. Often CT is current transformers, but in essence, there's the metering that is of interest to the customer, but there's all sorts of other measurements that a utility will make as part of its work and running the system. The underlying data standard for Green Button actually addresses all of those different types of measurements. So there's a whole bunch of different types of measurements. In fact, almost all measurements have units, SI units, have ways that they understand the values and the way that information is rolled up and aggregated. So you might have distributed measurements rolling up to a larger set. So the standard itself does include the ability to handle that full range of different types of measurements. So the answer is likely yes. We'd have to talk about the particulars in any one situation, but it is a general purpose data standardization capability.
Thank you, David. With this, we'll hand the floor to Jeremy Roberts, who will continue to introduce the Green Button.
Thank you, George. I appreciate it. Well, Dave covered a great deal of what happened to get to where we are today. I'm going to take, as he said, the baton and run the next few kilometers forward and let you know what the experiences have been so far, what we've learned here in North America, a little bit of the background of the Alliance itself, because we feel that that's an important piece of the puzzle that will have to be solved in Europe. Talk about what works today, what worked as we were pulling this all together. Talk about what doesn't work, because we want you to be aware of the roadblocks that are out there. And then talk about what's happening next. where we see things going in the near future and how that can be expanded as we move forward. So let's move on to the first slide, which is very straightforward, the green button. David Woolman spoke about how the green button got started. He talked about these priority action plans that were put together by a number of different groups underneath the auspice of a smart grid interoperability panel of experts in the fields, looking at everything from the ideas of those who were for creating such a thing, as well as those who were the skeptics, as you mentioned. And that was an important piece of the puzzle, to be sure that the green button was going to address all of the needs before it was launched. The other piece of that puzzle was that we needed to ensure that the green button had several different pieces to it that would handle a couple different ways for a customer to obtain their data and share their data. And so I'm going to talk about the two different methods here on the next slide. We have a method by which a customer can authorize a third-party vendor or provider of a service to obtain the information that they want directly from a utility with the permission of the customer. And I'll talk about how this works in just a moment. The second methodology is to be able to download these data yourself as a customer from your utility portal, the same portal you might go into to look at your usage information on the screen, or to obtain your bill in a PDF format or something similar, or to address customer support within the utility through their interface. So that same portal could be used to provide you these data in the green button format. So on the next slide, we'll look at what it all means. CMD, this connect my data concept, allows a third party to analyze continually, and this is typically on a daily basis, the data on behalf of what would become a mutual customer. Now, in a case of a utility that is providing services in an area where solar is prevalent, you may have people doing solar installations, solar financing, and the like. These require a great deal of information that is historical. So you can't just look at what's happening today. You need to look at what happened in the last quarter or the last half year or even full 2 years back. And so by analyzing hourly data within a 2-year time span, solar financiers and solar installers can give a customer an idea of the cost of solar for their implementation, the amount of solar they might need, and they also might want to provide some way to let them know if they could meet certain goals, such as net zero goals or shaving of peak time costs and so forth. And so in order to do that, they need these data. With Download My Data, you could obtain these data on a one-time basis for all of the 2 years worth of data that you need, analyze it, and then maybe come back a year later and download it again. So this concept of downloading the data wouldn't be something a customer would do on a daily basis, but might do once or even monthly to see how they're using the various forms of energy. And again, green button is much more expansive, as David has spoken about. We not only cover electricity, but we also cover natural gas and water usage as well. So it can be expanded to quite a long list of enumerated values of what it can carry in different data types. So for the question that came in about, I think it was current transformer and potential transformer types of measurements, whatever is collected at the meter is sent to the utility in the way that the utility currently obtains automated meter readings or even physical meter readings in the case of maybe natural gas or water. And then from the billing system of the utility, those are shared with the customer or with the customer's third party by way of that transaction over the internet. It no longer has anything to do with the meter. So you're not reading directly from the meter as a customer or as a third party, but instead you're reading from the billing system of the utility or the collection system of the utility. And so therefore, even utilities that are still acquiring data by drive-by or walk-by, or even by post once a year, could at least have that resolution of data available to their customer, and change that resolution as automated meters are rolled out to something more fine-grained. So on the next slide. Thank you. So on the next slide, what we're looking at here is where the culmination of what David Woolman spoke about earlier was putting everything into some sort of an semblance of off-the-shelf standards, if you will. So the core of Green Button sits within the North American Energy Standards Board's ESPI, which is the Energy Services Provider Interface. This is essentially the format of what it is that we're carrying, the energy information, the very centric types of information for kilowatts and for, in case of gas or water, the appropriate gallons or liters and BTUs and therms and cubic meters and so forth. The actual units that are being carried are irrelevant. However, they're carried in there so it can be used across the world. We also needed a few other things as well. XML is the primary format for the data that is stored in ESPI, but we needed it to be a little bit more of a relational database in a flat file. And so we utilize the IETF's Atom RSS feed mechanism. This syndication format allows us to be able to look at the relationship between one interval and another interval compared to something that came before it. So there are relative links in there that we utilize to increase the flexibility of that XML data. And then third, for the communication between entities so that a customer can authorize a third party to obtain the data on their behalf, we chose to use OAuth for this. We have since the first version, OAuth 1.0, which was initially put into the spec, we have changed that to OAuth 2.0. And what we found by doing some of these things is that we can constantly upgrade the standard as much backward compatible as possible, but allow the industry to determine best practices where we can adopt those best practices and not reinvent the wheel simply for our standard, for our narrow niche of the energy market. So by using the off-the-shelf industry standards, we are preventing a lot of potential issues with dealing with security and dealing with things that we don't have necessarily the full breadth of knowledge to circumvent. Next slide, please. So what I want to do now is take you right into the actual present of what we're doing, what that means for us. And on the next slide, we'll be passing the baton from the government onto us. So please, next slide. Okay, here, as we talked about, the creation of the Green Button Alliance was formed for primarily three good, really important reasons. And I'll talk about those in just a moment. NIST, as David Woolman already represented, worked very hard with a number of other groups, the Department of Energy of the US, the Smart Grid Interoperability Panel, which was first a loose coalition of interested parties, and then was formalized later. The Utility Communications Architecture International Users Group, the UCA IUG, was originally where we had been placed as a nascent entity, but since then have branched out into our own. And then, of course, the White House as the primary proponent or cheerleader of the entire platform. All of that culminated in putting the core of this into the North American Energy Standards Board so that we would have the wherewithal and the history that they have to be able to support what we're doing moving forward. So this was one of those things where it took a village to build this entity, and we built upon that. So let's talk about what we built within that core in the next slide. The core had been updated recently. And I want to point out a couple updates, which will give you a little bit of the history of what happened before it. But let me look at those updates with you for this moment. Right now, we're on what we call version 3.3. As I mentioned, we replaced OAuth 1.0 with 2.0 for confidential clients. We also upgraded the security requirements to TLS 1.2 as a minimum. We revised the energy usage information structure and definitions. And something new, we created a retail customer, a personally identifiable information data structure and definition. I'll stop here for just a moment and tell you about how that functions. With this platform, we actually separate data into two data streams. We separate data into usage data for one stream and personal information in another stream. This allows you to meet compliance with things like GDPR. It also allows you to ensure that if one data stream is compromised, the associated data are not compromised. Because they're in a separate encrypted stream. And so this is really an important piece of making sure that there's a privacy that goes beyond customer authorization and data in situ. This is really about being able to ensure that data in transit is also private and remains so even under the case of a breach. Next, we also deprecated some original use cases that don't meet the security requirements of OAuth 2.0. And we added a use case for the download my data. We simplified another use case for customer authorization process and documented the application programming interface formats. And this is an important piece that we're continuing to do today, is to help people understand how to work those APIs. So some of the work that we're doing with some of the assistance of these small grants that David Woolman mentioned that we get from NIST. On the next slide, I'll tell you a little bit more about how we got there. Dave gave you an overview of a little bit of what happened up until 2011, when Anish Chopra kind of branded this out for us as the Chief Technology Officer of the US. We had a White House call to action at that point. And as you can see on this line, the top line will give you a look at what's happened on the US side of it. And the bottom line will tell you what happened in parallel in Ontario, Canada. And I won't go through each one of these details, but you'll see right around the start of 2015 is when the Green Button Alliance was launched. And we began different efforts at that point. Certifications for Download My Data came next. And we began to help public utility commissions and public service commissions understand Green Button, what it could do for them. Educating them and answering questions whenever they had them to help them with their rollouts. And then, of course, Green Button certification for Connect My Data came later in 2018, and all the way up until the update of the latest version 3.3 NASB at the beginning of 2020. We'll talk a little bit more about what we're doing in this year and moving on forward. But the next thing we're going to talk about is what works. So next slide, please. So here's what works. I want to talk about 6 different things about what really worked. And I'll address the first 3. And I've already mentioned the very first one about using off-the-shelf standards and technologies. So next slide, please. Again, we wanted to make sure that we used things from the IETF. We wanted to use things from NASB. We wanted to use things that have been created already and not reinvent the wheel. The security and authorization uses off-the-shelf tokens that you'd get from a certificate authority. We use TLS and follow those increments. We look to NIST for their cybersecurity guidelines and adhere to those as best as possible where they fit into the scheme of things. So that's a real important piece for us. So if nothing else comes out of this, try not to reinvent the wheel as you move forward with these types of things. We also decided that we needed an open forum to discuss changes to the standard. Early on, there was a group that was formed ad hoc that was called the Open ADE Task Force. This is Automated Data Exchange. And this predates Green Button Alliance. And so when we formed the Green Button Alliance, we kept this group going. No membership is required for you to be a part of this. All of the ideas that are created within this Open ADE task force, which meets monthly, and when there's projects going on, it can meet even weekly. All of those ideas are brought to NASB and in some cases to the IETF for any changes or enhancements that we think need to be made to the standard. So this group allows anyone to participate from anywhere without any membership or registration whatsoever. It's absolutely completely open. And we think that's important because that way voices that can't afford to join or who might not be able to join due to restrictions of their governments or their companies would still be able to participate in this forum. And then we wanted to make sure there were very few barriers to implementation. We put things on GitHub for examples, and we allow you to do the same as you may make something for Ruby or for Python or something of that nature. You can put those things onto the GitHub for others. We don't have any membership requirements, as I mentioned, for the Open ADE task force, but even for the use of the standard. Obviously, the standard needs to be paid for, so you can purchase its standard, but you don't have to be a member to purchase the standard. We also don't have licensing fees. And you can, the Department of Energy has allowed the use of the green button term and the downloading looking logo to be used by folks who are implementing it without a licensing as well. So this is really one of those things where this public-private relationship that was initially created, this handing off of the baton, really came into play in helping drive the acceptance of this as an open standard. The other piece of that puzzle, of course, is that we have taken the standard even further by trying to do certain things like the separation of data. So next slide, please. By separating the data into parallel streams, one being for the usage information itself and the other for personal information like addresses or names and meter numbers and those types of things, we reach a higher level of compliance to some of the security requirements throughout the world. And this is no easy feat, but those two data streams are mappable again through unique identifiers for each interval of measurement. We also look for community acceptance. Non-voting governmental participation, as David Woolman noted to you, they are a member of the board of directors of the Alliance in a non-voting and ex officio capacity. This allows governments to participate without feeling as though they have to take sides, if you will, when conflicts arise. We also don't lobby. We made sure that the Alliance is only there to educate and provide services and not to lobby in any one direction or another. We're happy to provide information when it's asked for, but we don't actively seek to push that information. And we wanted to be a single place for all of the different resources. We wanted to be the place where people could come to discuss things, whether that's in a membership Slack channel, whether that's openly on the GitHub or in Zoom conferences that we have with our members or with you in this case. We also want to be able to provide technical education, which of course comes at a cost to us. And so therefore we provide it to members if you're interested in becoming a member. We also provide to non-members for a cost on an hourly basis. We provide testing, but you don't have to be a member to participate in the testing. And we break apart the testing into the cost to test as well as the cost for the certification in a similar way to ISO rules. And we provide this, the support for the standardization of those enhancements, as I mentioned before. In that Open ADE task force, we push those to NASB. And then the NASB membership can work those through the standardization channels. So all of these are things that work. Next slide, please. I certainly would be lying to you if I said everything worked. And so I want to talk to you a little bit about what doesn't work. And two particular items are the most important. And those are the things I think it's important for folks to look at this stage in Europe. Next slide. Don't wait to form a trade group. When we created the Green Button Alliance, it had been about 5 years past the initial forming of the groups, of the Priority Action Plan number 10, Priority Action Plan 20, and so forth that went into a lot of these efforts. By waiting to form the trade group, many people had attempted to roll out their implementations of the standard to what they believed was the right implementation and the right interpretation of those things. And that made it very difficult. It also made it difficult to coordinate efforts. We had several different websites, one that the government had provided, another one that the government provided, yet another arm of the government provided, yet another one, all of them with great intention, and yet not a single place where people could go to focus on that. The greenbuttondata.org became that single location, but yet branched out into many other locations. We have kept that going as a consumer and general awareness website, and then of course added the greenbuttonalliance.org. And between the two websites, we've been able to corral all of the various things throughout the internet to give people a single focus. But again, it was a bit like herding cats, where they were wandering in many different directions, and we wanted to ensure people could find the information in one place. Also, the use of the terms and the logos without an oversight or compliance made it a little bit difficult. While it certainly allowed people to get out there with their green button implementations, there were different flavors of green button by the time it was by the time the alliance was established. And so we wanted to, if in hindsight we would have pulled that in a little bit earlier, so that wouldn't be an issue. And then lastly, in that same vein of the trade group, there was no registry for implementations. So when customers would come to us, or third parties who wanted to provide apps would come to us, they would ask us about where these things are found. We wouldn't have the answers for those. We'd have to go and look for them ourselves. We also had too many mandatory parts. And so we needed to make sure that too few mandatory parts. We needed to make sure that we had minimums that folks could meet, but we also didn't want the least common denominator to be that which was implemented. So that's what worked and what didn't work. Let me skip forward and tell you what's next. Okay, one more slide. All right, so what's next is we have some regulations and legislations that we're working on to put on a statewide basis. These are things that are happening in various different states and provinces, mandates for data sharing. We're also expanding into other countries. The Korean Smart Grid Association is in the process of translating the standard into Korean. We're looking at certification expansion so that folks can ensure their compliance to the standard. We're looking to create that registry of implementations, basically assembling an app store for folks, a go-to place to find things. And we're working on enhancements to date. So again, working with NASB and the IETF, looking at tools for users and templates for the industry. And the next slide is how you can reach us. I know it was a lot, and I apologize for trying to cram all of that into a short spell. Hopefully there aren't too many questions and we can move you forward.
Thank you, Jeremy. We have to move into the next session, which is really unfortunate, as I have about 5 or 6 questions myself, and I'm sure a lot of people have loads more questions to you. Perhaps we can arrange some email questioning and answering in the end. In the interest of time, as we are now in the panel discussion, we have to move on. So thank you so much, Jeremy. It was a great presentation to see, and there's many good learnings of what to do and what not to do. So thank you for that.
Thank you.
So now up for the panel on grid operators versus emerging market players. We have the innovators themselves, and on one hand, and on the other, actually we're all in the same boat, but the grid operators on the other hand. So handing over to Kalle Kokk, who's the moderator of the panel.
Thank you, Georg, and good afternoon to everyone. At least from Estonia, we can say good afternoon. Actually, we're approaching the end of the business. I'm happy to moderate this first panel of today. We have 5 excellent speakers here. I first ask each to make a very short elevator pitch, just using 1 or 2 slides, however they decided to do. The title may sound a bit provoking, and that's of course intentional. So we have the view from the grid operators, the regulated domain, and we have the view from some, let's say, startups or other private initiatives from both sides of the Atlantics. So not to waste more time, I will turn to the first speaker, which will be the Maximilian. He's the Information Security Officer at the Distribution System Operator in Austria. Also, he acts as the Innovation Manager and Smart Grids Project Manager at EDSO, which is one of the largest European DSO association. And also, he's the chairman of Euroelectric. So Max, the floor is yours, and your 2 or 3 minutes are on now.
Thank you, Kalle, and good afternoon to everybody. As a DSO and as a representative of the EDSO Association, I'll like to tell you that we have established and also released a paper which is called, and you see it on the screen, Facilitating Customers' Energy Data Management and Interoperability. And that is our understanding of the data issue of our business, of the DSO business. So the data we are talking of and the data we are handling is the use and contract data, of course, because the users are connected to our voltage level, to our grid. And of course, we have to take care of the market as far as we are involved, not very much yet. But the grid data we are handling, we run grid voltage levels from 110 kV down to 400 volt here in Europe in different subsets of that. We are handling the meter data of our customers and of course external and support data. So having all this data in our hand and be responsible for that, we see ourselves as the neutral market facilitator also in the future with the data management of our customers whose unit are connected to us. The data access therefore has to be transparent, non-discriminatory, and of course is near real time. And we also take care on data security and data privacy issues. The roles and responsibilities we as DSOs see ourselves, and this is also supported by the Clean Energy Package, is that we will follow and support emerging market functions which will come up now and requirements regarding the data management of these market functions. And of course, we support our customers who are turned to be prosumers in the future. Of course, we have a very good connection to the TSOs with their operation of the voltage levels above our grid. And then, of course, the suppliers, aggregators, and other stakeholders who do business with the customers who are connected to our grid. So we are emerging new services in the energy systems, and this is also integrating the data and the management of the data with demand-side response, concession management, and local balancing mechanisms. So this means, as you can see, that our understanding is that we will support the flexibility services. We, of course, continue it. This is also what we did in the past, TSO planning and operation, cooperation from the DSO side. And we offer also the data for the old, traditional, classic, and also for the new stakeholders who do business with our customers. So that is what our understanding. Thank you, Kalle.
Thank you, Max. And we can switch to the next slide. And I see it will be Feder. Feder is enterprise architect at Energinet, which is the Danish transmission system operator. He has been focusing on harmonizing the data exchanges in the European power domain and implemented the Danish data hub. He's very active in ENTSO-E and in IC. Feder, please.
Thanks, and thanks for inviting me. As is present, being an architect, I tend to talk in pictures rather than text. But anyway, so what I've been seeing is that we have this massive shift from centralized thermal power plants, as you see in the lower left corner, towards decentralized production units. This can be either thermal or renewable. That actually depends a little bit on the local, you could say, community or possibilities that you have. This goes all the way to rooftop PVs and to wind farms. What you get out of this is that instead of being able to basically pick up the phone in the control room and call 5 central power plants when you have an issue with the grid, you have to control hundreds of decentralized units. When you couple this with the fact that you have a lot of renewable production that is uncontrollable, you have a situation where just managing the grid requires a significant increase in data. At the same time, as you can see, when we add renewable production at such massive scale that we do, at least in Denmark and in certain parts of Europe, because the renewable production is not flexible, you will have to introduce some kind of flexibility in the system. That is, you need to move or to incentivize the end users to be more flexible in their consumption, so they can sort of move towards supporting the system rather than supporting their own decisions. So, meaning I need more data if I have to make a qualified decision of when to turn on my dishwasher, and I don't have that data yet. So what we can see in order to support this is that in order to be able to balance the grid in a sense where you have these thousands of decentralized units, most of them running or producing from renewable sources, so they're actually not really dispatchable, is that you need to combine a lot of different entities in order to get the flexibility that is needed to balance the grid. So we no longer have this vertical level of integration from the system operator through the power plants to the consumer. More, it's going to be a bidirectional graph of influences that needs to be activated. This requires an exponential increase in the data that needs to be exchanged to make this whole thing work. And at the same time, we have this ever-increasing threat from cybersecurity attacks on the integrity of the grid. This leads to, on one hand, we want to have more actors to be part of the balancing of the grid. On the same time, all things being equal, in order to make things secure, we need to increase the requirements for these actors. And the only way that I can see that we can address these orthogonal requirements is to apply standards throughout the system, to promote standardized systems and standardized communication options, to make it easier for actors to engage in this system in a reliable and cost-efficient way. So that's our take on it, is to promote standards for interoperability in order to enable this meshed exchange of information that we've been seeing previously. Thanks.
Thank you, Feder. Next slide. And we now have heard two representatives of the system operators who are the ones that can facilitate the data access and and easy availability of data. Now we have 3 more speakers from the other side, from the non-regulated side. So they are the people who actually need those data. So first we will have the company utility API, and the person behind it is Daniel. He's the founder and CTO of that company. It's based in United States. He's also the vice chair of the board of the Green Button Alliance, and is an active contributor at the California Public Utilities Commission. Daniel, the floor is yours.
Howdy, everybody. I'm Daniel. I'm the CTO of Utility API, and Utility API is a infrastructure platform for providing third-party access to utility data, and also being able to submit data back to utility infrastructure. So we are actually the company that implements a Green Button Connect system at a utility. And so if, for example, we have implemented Green Button Connects across the US. We are probably, actually, yes, we are the largest Green Button Connect implementer that has registered the most third parties or have the most third party distributed energy resources like solar, energy efficiency companies, battery storage companies, electric vehicle companies, energy consultants, anybody who is needing to get customer data. They can connect to our system and send data requests to customers in a very streamlined and easy to use fashion, and get that data instantly to be able to integrate into their calculations, for example, like Jeremy mentioned, for a solar quote or some other reason. So we are actually the web platform that you can use to integrate a utility backend, as Jeremy mentioned, with an external facing standards compliant Green Button interface. So I'll leave it there. We have generally been focused in the US. However, we are very interested in expanding internationally. And so if you have any questions or are looking to implement a Green Button Connect, please let us know. And I'm happy to answer questions on the drivers and motivations of third parties themselves, since we have over 1,000 third parties using our platform to request data from customers. Thank you.
Thank you, Daniel. I think it's very clear what you're doing. If we move on, then we have Michael. Michael is the co-founder and president of also US-based Mission Data Coalition, a nonprofit advocate for energy data portability. He has experience with building automation, energy management, metering, and public utility regulation. Michael, please go ahead.
All right. Thank you, Kalle. It's a pleasure to be with you. It's early morning my time. I'm on the West Coast. So Mission Data is a nonprofit trade organization, and we have about 30 members that you can see listed there. And our job is to increase energy data portability across the US. We're the primary advocates for a Green Button Connect My Data nationwide. In the US, the federal government has a very limited role, almost non-existent role in the regulation of retail electric service. That's all done at the state level. And so it's a state-by-state battle for us. And so you can see on the map in the last 7 years or so, we've established policies covering 5 states that require Green Button Connect My Data. And we're in discussions in another 8 or so states to expand those policies there. So I have if you can go to the next slide, I have just a couple of lessons learned that I wanted to quickly mention for you, given the European audience. The first is I would plan for potentially bad user experiences. The Green Button standard is silent on user experience. And so what happens when a utility or data provider does a bad job? How do you remedy that? This is something that we had to learn the hard way in the US. Number two, plan for poor quality. So what if there are system outages? What if API requests return errors? This happens a lot in the US, and it's something that we're struggling with. Our state regulators are really ill-equipped to deal with this type of problem. They set electric rates. Keep in mind, most of the US has vertically integrated utilities. And so they are really not fond of distributed energy. They're not fond of other entities getting access to information. They would prefer that, frankly, all of the distributed energy future just, disappeared or didn't happen. And so there's no real incentive for them to operate the system at a high level of performance when it comes to their Green Button Connect platforms. That's something that Utility API is thankfully working to improve. And then the last lesson learned has to do with centralization. So the US, you may not know, has over 3,500 retail electric utilities. And so consistency is an extremely big problem. This is why screen scraping today is probably the dominant method of data transfer. And so there are some state initiatives, one with Smart Meter Texas, to bring all of in the competitive areas of Texas, which is 85% of the state, bring all of that information into a green button type of format. So it doesn't matter whether you're on Western Texas or Eastern Texas, you can access your information in the same way. And similar initiatives are underway in New Hampshire and New York. And so I would encourage you to think about this. The costs to distributed energy resources and innovators proportional to the number of API endpoints that they have to support. And so supporting 3,500 API endpoints is really difficult. We want to try to reduce that as much as we possibly can. Thank you.
Thank you, Michael. And finally, in this panel, we have Simone. He's the CEO and co-founder at Europe-based cleantech startup FlexiDAO. He has expertise in energy management consultancy, wholesale and local electricity markets, smart distribution systems, and blockchain applications for the energy sector. Simone, please, you're on now.
Yes, thanks a lot. Thanks a lot for the introduction. So first of all, FlexiDAO is a software startup. We are based in Barcelona and Amsterdam, so in Europe. And we are fundamentally different than any other speaker from this panel because we are not an infrastructure provider, we are not a trade organization, but we offer client-facing services. So for the end client. Generally speaking, our mission is to build software solutions to help consumers of any size consume the so-called zero carbon electricity in a transparent, environmentally impactful way. But our long-term vision is the so-called 24/7 green for all. So the ability for any consumer to be able to match its consumption to the available renewable energy production as the main mean of decarbonization of the grid. What does this mean in practice? If you can please go to the next slide. So we currently have one platform in the market, but we're working in 9 countries with around 10 utilities and 23 corporate buyers. Essentially, Respring is a platform that is designed to offer transparent information on the global energy procurement of a renewable energy buyer. This means that the platform collects and aggregates energy certificates from different standards, the guarantees of origin, RECs, IRECs. It collects consumption data and production data. And we do that to help the energy managers and sustainability managers of our corporate with their reporting. So to add credibility to the reporting, but also to add elements that current certification schemes do not provide, like, for example, the synchronicity between consumption and production, so the time element of renewable energy sourcing, to help them make a decision to optimize their contract, monitor costs, and make procurement decisions, and then indeed also to share data more reliably with auditors. So this is our commercial offering, and you might see that consumption data and production data is extremely key for us. And we are essentially the data users, and we need our data provider to grant us access from the data of the data owner. And right now, if you can go to the next slide, we just summarized a bit what is our experience so far when it comes to data. And when I talk data, I mean private metering data, so settlement data from fiscal meters or revenue grade meters. Essentially, what we think in order to deliver our service, also bearing in mind of our 24/7 vision, where consumption should always match production, and certification should happen on an hourly granularity level, not yearly, like with RECs and guarantees of origin and the likes. So first of all is hourly settlement data from the fiscal meter in terms of frequency. The availability is day plus one. So ideally, we think we should be able to get the data the day after the physical delivery, at least the preliminary data. And then when it comes to the settlement, it can be later, but we think that already data from the fiscal meter should be available the day after. The format, we believe that accumulated meter readings are much better in order to be able to manage gaps and to manage errors compared to increments. And the process, of course, said many times, non-discriminatory, both for data user and data owners. And I will explain why we think that currently in Europe, this is not the case. Well documented, again, not the case in Europe. And with authorization process, not digital. Again, not the case in Europe, at least not in the majority of the countries. We currently work in many different European countries. And the reality is that we had to take on ourselves the work of mapping out who is the data provider in each country. There's no information available in Europe on like who's the data provider in each country. Only few countries offer this. Two are here, for example, Energinet and Elering. But this differs a lot. In France, for example, the DSO. In Spain, there's a battle between TSO and DSO, and I can go on. The administrative and technical process to get authorized is never documented. Of course, if the provider is not available, the process is even less. The few countries like, for example, Estonia and Denmark that offer the service always require a national VAT or an electronic ID, which basically cuts out every service provider that is not of the country. And also, it's very, very hard to find which users are connected and which is the data availability. So this is the current status, which makes our life as a data provider extremely hard. And I'm not even entering into having a standardized data. It's really, we don't know how to access it. We don't know who to talk to, and we don't know who the process is. And this makes it very hard as a service provider to do our job, essentially.
Thank you, Simona. We are quite close to the original end of our panel session. However, I would like to take a couple of questions. Please post them in Q&A as well if you have any. Let me start with one myself to Max, and also similar to Feder. And what are the lessons? How do DSOs and why themselves in the role of core data manager in this energy business? Max, if you could put an answer from a DSO perspective, and really short, please. Did we lose Max? I guess so. Maybe Feder, you can take the same question from the TSO perspective.
So you asked about the master data responsibility, or
I'm asking why and how TSO, transmission system operator, sees themselves in the role of core data manager in the energy business.
Okay. That is actually quite clear, because as from my perspective, a TSO's data is not actually the property of the TSO. It is the property of the community, because we need to provide as much data as possible to the, you could say, energy community in order to promote this flexibility in the grid to the maximum extent that we can. And I appreciate that Energinet was referenced as being one of the leading TSOs in this game. I'm sorry that we are still relying on a national ID for this, but that's basically the way we could make it work in a reasonable way with the current technology. But we are trying to push the boundaries of how much data we can publish in order to promote aggregators in identifying possibilities of providing flexibility in the grid. So that's our position to this.
Thank you, Feder. And I think it very much relates to this, let's say, pan-European data exchange, which we will hear more in our last presentation today. Maybe just before the end, I would like to give a chance to the other speakers of this panel to react to the question: what are the lessons learned from your own experience with energy data portability? Whoever wants to take. Michael, maybe you could start.
Sure. I would look to the work that Australia is doing right now on the consumer data right. They began in the banking sector, but are now doing some really wonderful work on energy. They are looking at some of the issues I mentioned before about the user experience. There's a very open and collaborative process being led by the federal government, which I think it's fantastic, and I think they're going to get to a more widely used system nationwide a lot faster than the U.S. We've been while the federal government has led some of the initial standards development work, it's really up to the states to implement. And so the nice part about Australia is that they have a stronger federal government that is essentially mandating it for all of the states, whereas we don't have that capability. So for us, we have to go state by state, and it takes a lot longer as a result.
Thank you. Daniel or Simona, do you want to take the same question, please?
Sure. So in our experience, one of the major lessons learned from trying to develop data sharing platforms in the United States is that what we found is that there's a lot of expectation of trying to build an energy specific system from scratch, when data sharing and data access and online authorizations and all of that sort of stuff have been widely implemented in other industries at scale for a significant period of time. OAuth 2.0 has been around for a decade now and has been used by enterprise SaaS companies, has been used by finance, has been used by healthcare. And so really looking to other industries for inspiration on how to streamline authorizations and streamline data access and really assist in ease of use and the user experience, I think is an important lesson that we should always keep in mind whenever developing data access, is to look to other industries for inspiration.
Thank you. And Simona, if you have one final sentence about this.
Yeah, so I would say so far not great, but optimistic based on the work for Energinet and Ellering and the likes. So far, access to public data through, for example, ENSOE, it's been a great experience. I think there's a great deal of transparency in Europe, and this is making our life very easy when it comes to CO2 calculations. When it comes to private, I think there's still a long way to go. And UX, honestly, as a service provider, is the minimum levels in central countries not existing. But at the same time, I do see that there are a lot of initiatives, and this is what makes us optimistic that we are on the right path. And also Europe, hopefully, eventually will have something like a Green Button Alliance in place in as many countries as possible.
Thank you. With that, we are happy to finish our first panel. Thank you, our panelists, and pass back to Georg.
Thank you, Kalle. We are now into the break. Please ignore the 10 in this text. Let's shorten the break to 5 so that we are, as we are 5 minutes already into the break. So let's come back 10 minutes before the hour. Sorry, let's come back in 5 minutes time. The break is 5 minutes. See you again in 5 minutes, 5 minutes time, not 10. Hello, everybody. Let's begin gathering back from the break. It is soon time to continue with presentation. Let's give 1 more minute for people to gather back. And hello back, everybody, from the pause. I hope you are now back and have made it back to listen to the next presentation, which will be given by Eric Lambert, who's at ETF, and we'll talk about the My Energy Data Standard. Thank you, Eric, and floor is yours.
Yes, can you hear me? Good. So, good morning, good afternoon, everyone. So I will speak about 2 profiles based on common information model, which are named UMED market profile and UMED metering profile. So UMED means European My Energy Data. And I will give also this presentation on behalf of Mr. Nativel from the French DSO Enedis, who is also member of the standardization group CGSCG, Coordination Group Smart Energy Grid, which is part of Sensenelec ETSI. I am also member of several IEEE technical committees, and in particular TC57, which is developing a common information model. Next slide, please. So this is the agenda. First of all, I will go briefly to the European context, because maybe some of you are not aware of this context, as some associations, standard organizations, and the regulation. Then the core topic of my presentation will be the complementarity of these 2 profiles, human market and human metering, and the conclusions and the next steps. Next slide, please. So just briefly reminding the European organization context, we have the European Commission with different Directorate General, in particular the DG Energy and the DG Connect. We have a regulator through 2 associations, the CEER and ACER, which is drafting the network codes, the grid codes. And we have also main organizations representing either TSOs through ENSOE, and DSOs associations, which, as you can see, we have several DSOs associations with a coming new DSO association based on the requirement from the regulation, which will be named EU DSO, which will be the counterpart of ENCSOE. So it will represent these already existing DSOs association. Next slide, please. So on this slide, it's just a reminder about the standardization and user groups landscape. So in each European member state, you will have standard organizations, but we have standard organization at the European level, and we have standard organization at the international level. So we have for general standardization, ISO and CEN, respectively. For electrotechnical standardization, we have IEC and Senelec at the European level. And for telecommunication standardization, we have ITU at the international level and ETSI at the European level. Also, at the European level, we have the JRC, so the Joint Research Center funded by the European Commission, which has several premises in Europe. which is developing research as it is indicated by its name. And we have also technology platforms, several technology platforms. On one of these platforms is, for instance, ETIPSNet, which is focusing on smart networks for energy transition. We have also initiative like Bridge Initiative funded by the European Commission, which foster knowledge from different European projects funded by the European Commission. And it's really important to have this kind of structure in Europe to disseminate knowledge, to share experience between these European projects. And on the right side of the slide, you can see also some users associations. Some of these associations are well known, like UCA International User Group, which hosts the SIM user group. And for metering system, we have the DLMS User Association, which is developing also standards, user experience for smart metering systems. Next slide, please. So it is a very important slide in order to build this European interconnected electricity market. I will show this slide. I'm showing this slide from ENSOE. So on the left part of the slide, you have the regulation, the European regulation drafted by ACER and ENSOE. And this regulation is supported since 2009 by ENSOE and also by IEEE standards. And so you can see on this slide for market data exchange related regulation, we support this regulation by IEEE series of standards 62325. For other kind of regulation, we have developed in Europe and with IEEE what we call the CGMES standard, the Common Grid Model Exchange Standard, which is well known by all TSOs in Europe. As you can see on this slide at the bottom, we have the last regulation, I would say, the Clean Energy Package, which has a focus on active system management data access, which has also a focus on TSO, DSO, significant grid users information exchanges, and which want also to address interoperability at the retail market level and with retail market participants. And all these regulations will benefit from the experience of having implemented and used already the common information model and its related profile supporting the European regulation. So next slide, please. So at the European level, at the Sense and Advocacy European Standard Organization, we have set up what we call a coordination group for smart energy grids. And we have two working groups in Sense and Advocacy. We have a first working group, which is a working group Clean Energy Package, which has analyzed the European regulation. And based on this analysis, it has defined a list of standardization gaps that the second working group, the working group standard working group, has classified, set up a kind of merit order list of these gaps and decided if these gaps had to be solved either at the European level, at Senelec level, for instance, or at the IEC level in several technical committees. And these gaps, some of them are feeding IEC documents that I mentioned at the bottom of this slide, a document which lists the top priority standards development status in the domain of smart energy, and another very important document, which is the Smart Grid Standardization Roadmap, the 63 all 97 document, which is also freely available from IEC. So now we can go to the next slide. So now the core of the discussion is complementarity of UMED market and UMED metering profiles. Next slide, please. So in 2016, the European Smart Grid Task Force Expert Group 1, which is focusing on standards on interoperability, provided a final report named My Energy Data. So it was also close to the regulation at that time named Winter Package. And this report recommended Can we go to the next slide? Yes, thank you. Sorry, I have an unstable communication link. So the European My Energy data is linked to a European regulation, which is named here, the 2019-944 Common Rules for the Integrated Market in Europe, with two articles, Article 23, Data Management, and Article 24 on interoperability requirements and procedures for access to data. And as I mentioned, Sense and Efficacy anticipated this regulation, identified this gap, and we launched a standardization work at the IEC level, which was endorsed by IEC 62325-451-10, which is the number of this standard. And it was published as an international standard last year in 2020, which is related to the use case download my data. Next slide, please. So this is on this slide, the storyboard, I would say, about My Energy data. First of all, it started by a funded European project named FlexiSensi. And this project involved European DSOs like the Italian DSO Enel, Enedis, the French DSO, and DESA, Vattenfall, the Swedish DSO. And they already worked on a common data format, and it was based on SIM, and we named it what we call UMED metering profile. Then we brought this initiative at the European level to start a standardization work, and we decided to bring this work in ICTC 57, Working Group 16, which is dealing with SIM for market standards. And we had to change our modelization and to comply with this SIM for market, which has developed the European style market profiles in Europe. So this is a profile that we will find, that you will find in the IEC standard 62325-451-10 published in 2020. And at the end of last year and beginning of this year, we started to discuss about standardizing the complementary profile, UMED metering profile, which is based on other kind of SIM classes, interval block, interval reading classes. And we started this discussion in IEC at the beginning of this year. So we can go to the next slide, please. So here, using the well-known smart grid architecture model, where you find the domains from generation, centralized generation, up to customer premises, and you can find also the SGAM layers from the process layer up to the market layer. You can we describe these two profiles. So the UMED market profile is more dedicated to the market domain, as I already mentioned, and used by market participants, essentially. With this second UMED metering profile, we are more concentrated on the metering domain and IT systems. The users of this complementary profile will be digital users, IT teams doing, for instance, data analytics. And as you will see, UMED metering is closer to US green button than UMED market profile. And here you can see also the link from the smart meter developed in Europe. And I will remind also that in Europe, through the M441 metering mandate, we decided to develop, to roll out smart metering systems using the COSEM IEC standard, which is complementary to also to SIM. So you can see the value chain from the meter up to the metering systems and market systems. We can go to the next slide, please. So here, it's a focus on the contextual model of these two profiles, human market profile and human metering profile. So on the left part of the slide, you have a list of classes extracted from the common information model. And all these classes and their relationships and attributes for each class are named the contextual model for human market. On the right part, you have the contextual model for human metering, also using common information model classes around usage point, around meter reading associated to meter and customer, using interval block, interval reading. On human market, we are more focused on the central class, which is used in ESMP, European Style Market Profiles, the time series class. So these are equivalent and complementary. We can go to the next slide. So what we've done in 2020, we have aligned these two profiles, human metering and human market, on the last common information model version. As you know, SIM is evolving. I would say we have a new version every year due to new use cases that we have to address. For human market, we are also aligned with the European Style Market Profiles managed by ENSOE, which has also a version. We have also experimented with these two profiles, two tools, in order to derive our profile. So from this contextual model, we are able to generate an XML XSD syntax. So for human metering, we used a tool, license-free tool, Mozarus, which is a Nadine of Enterprise Architect. And the human market profile has used another tool, which is used by ENSOE, which is a SIM syntax chain, which have also versions. We have also conducted real implementation of these profiles based on real data from the French DSO Enedis. So this consumer data from the Linky smart meter rolled out in France can be transferred, can be modeled using the human market profile or the human metering profile. So we have portability between these two profiles. We can go to the next slide, please. So a conclusion on next steps. So human metering profile is ready for a new IEEE standardization document to complement human market profile. Human metering profile is in fact an informative annex of the standardized IEEE document supporting human market profile. So we can extract, and we already extracted this informative annex, and we are discussing how to standardize this document and to discuss some SIM issues that we could have on this human metering profile. The portability between human metering and human market has been tested, as I mentioned on the previous slide. So the compliancy test, some compliancy tests could be foreseen for these two profiles. And we could also set up interoperability tests at the European or international level. We opened the discussion also on this topic. And as I mentioned, we already started discussion at the international level. So we presented this work at the last IEEE TC 57 SIM working group meetings, and specifically in working group 14, which is developing the SIM for smart metering systems. We can go to the next slide. So I thank you for your attention. If we go to the next slide, and this will be my last slide, I wanted to thank participants of this standardization work. I don't know if you can hear me. On the last slide, another slide, I want to thank the team, the IEEE TC 57 Working Group 16 team, and Flexi participants. So this ends my presentation. I am open for questions during the roundtable. Thank you very much.
Thank you, Eric. We are now into the panel. So Rudy, here you go.
All right, thank you, Garrick. And our next panel session that we'll be starting now continues the discussion on standardization initiatives. Eric will be part of that panel, and I thank him for the excellent overview of many of the standards activities that are going on. So we're going to actually go to some of the other panelists before we come back for discussion on questions. And our first presenter on this panel, and by the way, this will also be done as we did for the earlier panel. Each panelist will be talking just for a couple of minutes, and then we'll do a more interactive dialogue. So our first panelist is Bas de Vrin from Alliander. So I'll turn it to Bas. I think you're muted. So I'm not hearing Bas right now. I'm not sure if we have an audio problem. All right, in the interest of time, while we try to sort out what the problem is for Bas's audio, why don't we reverse the order? So let me switch to Kalle Cook from Ellering. And Kalle, we met him earlier, and we'll see if we can figure out Bas's audio problem while Kalle speaks.
Thank you, Rudy. Indeed, hello again. This time I'm representing not only Ellering, but also one of the large research and innovation project in the energy domain in Europe. It's called EU SysFlex. It's co-funded by the European Commission. And in this project, we have many partners across Europe. And amongst others, we are investigating issues related to the data management. If you click the button, so what we just to illustrate some points we have completed and really kind of very well related to Eric's presentation, and Eric is also involved in this project. So what we have done, we have identified a set of data related use cases, and here in this figure it's illustrated how many of those use cases are covered by some individual standards and specifications or a series of standards. So we have made this kind of gap analysis. If you click again, please. Then here you see some of those use cases, and I only picked the ones related to the data management, to the, let's say, private data management, which is our core interest today. And you see something like how to authenticate data users, how to give consents, etc. And for each of those use cases, there are some requirements we identified where we think that the current standardization is not sufficient. If you please click once again. Then what we did, we linked each of those use cases to business objects. So there are specific business objects that are included in this use case, and this is relevant for the next step. And you can click finally one more time. It's really not visible, but it illustrates that what we're doing now is the SIM profiling. So we have decided to take the SIM common information model as a basis for this EU-wide data exchange, and try to translate these private data use cases into the SIM. And you understand it's not there today. There is what Eric said, that yes, you can exchange the meter data itself, but for example, the information or data related to the consents themselves, it's not there in the SIM. So what we are now discussing and provoking probably very soon is to extend the SIM towards these domains as well. Thank you.
Thank you, Kalle. I just want to check if we can hear Bas now. Bas, you want to try your audio?
Yes, can you hear me now?
Yes, great.
Okay, excellent.
Yeah, Christina, if we could go back to his slides. Super, thank you. Go ahead.
I will give you a very brief update about the development of an energy data sharing scheme. This is like a set of rules to enable the sharing, to improve the sharing of energy data. And a couple of things are new in the new framework that's open to all parties, whereas the current system of sharing energy data is limited by regulation to regulated parties. The new system will be open to all parties, and all parties, and like all suppliers, but Also, price comparison websites, completely other parts who have nothing to do with energy but are interested in energy data. They will all be able to join the new system and also to join the development of the data sharing scheme. It will be important to get an equal level playing field, so all market parties should get access on the same level. And of course, we want to put the customer in control so that they can share the energy data with consent, that it is transparent who is accessing the data, and that they can always revoke their consent. And from a DSO perspective, we are doing pilot experiments to give input to the development of the scheme, and we do this these experiments with energy sharing of energy data always with market parties, so it's also always a co-creation. And that turns out to be quite successful because all parties have their own experiences. The DSOs hold a lot of data, and the new system will have as a guideline that the consent should always be given to the source, to the data owner. That's often the DSO. But one of the key challenges for that is to identify online consumers, online customers, and to determine which data they're entitled to share. And that's not so much about identification, because to know the name of a person doesn't say anything about which energy data he or she can share. So we're interested in the relationship with endpoints or addresses that relates to an endpoint. So that was the main challenge. We have come up with some solutions. We tested them in practice, and now we had some successful pilots. So we putting that as input for the development of the energy trading sharing framework. And also interesting because now we have a basic central IT solution for sharing energy data that also turned out to be interesting for financial sector. And because we have this central IT solution, we're now preparing a pilot project with the financial sector to share energy data for green loans. And because we have the central solution, the financial sector has a central solution. So now we will be trying to do sharing data cross-sectoral. So that's already one of the benefits from the experiments. So that was the brief update.
All right, thank you very much, Baz. We'll go to our next speaker, Garrett Fakema, who's with EDSN, also involved with EBIX. So please go ahead.
Thank you. Thank you for the invitation. I'm speaking here for EBIX and not for EDSN, that is the data hub in the Netherlands. That was more or less covered by the previous speaker, Bas. So you can go to the next slide. I will tell you a little bit about EBIX and make some statements here and there. Well, EBIX is an association of organizations from, let's say, 11 countries in the European energy market. And the aim is to model and harmonize downstream market processes, not upstream, that's more NSOE kind of stuff in electricity, but it is downstream processes for electricity and gas mainly. These models are, modeling is done in the business requirement specifications. We modeled most processes, and the aim of the modeling, of course, is the interaction between the parties in the processes. For instance, the customer move or switch of supplier are processes that are modeled, but we also modeled processes with measured data, consumption data, meter data, etc. And also EBIX has made a business requirement specification for administration of consent, where you can manage the consent, give consent, withdraw consent, terminate consent, and also can check consent. We describe what information flows are needed there and how processes run. Some observations: identifying a customer is not a problem and is not market specific. There are a lot of customer identifications schemes, for instance, using from the banks or from national authorities can be used. The authorization of market parties and identification of market parties and authorization of customers is doable, sometimes hard to do, but it is quite doable. But in my view, the authorization, or sorry, the linking of the rightful customer to the accounting point, the delivery point or usage point, whatever you want to call it, is still a challenge. What you see is a lot of countries take shortcuts, take the easy way and say this is it, like Bas told, as long as we can match a customer to an address, then it is okay. But how are you sure that he is liable to the data that is produced at that accounting point? That is the big challenge we see ahead. And I would like to see a good solution for that. I don't know how my energy data or the green button has resolved that. Maybe that can come up in the discussions. So there may be a lot of tools for conversion between countries. Europe is also divided in a lot of countries, as you know. So IDs are mostly countrywide specific and not recognizable between countries, and there are tools that can enable country border crossed ID conversions. So that's a little statements from my side.
Right, thank you very much, Gerrit. And then our next panelist is Valerie Rafe, and Valerie's from the Florence School of Regulation. So let's go to Valerie.
Thank you, and thank you for the invitation. So indeed, in Florence, we have been following this debate on European interoperability in the last months and years very closely. And I think what we tend to forget when we talk about the nitty-gritty of the details is often the overall objective. And sometimes we have to remind ourselves why we're doing all of this. So it's really the objective to have at some point a decarbonized, integrated, a flexible and interoperable energy system, to have competitive markets and to have customer empowerment. And interoperability, as we know, is an enabler for that. And standards, of course, support interoperability. So what we currently see in Europe, at least from an observer perspective, from an outside perspective, is that there are a lot of initiatives emerging at the various levels, so both at the European and at the national level, and they have different backgrounds. Some are driven by legislative requirements, others are driven by certain needs or visions, let's say, of groups of stakeholders. And I think the open question at the moment is whether the industry and these initiatives by itself will at some point manage to converge somehow to a set of solutions, let's say, and to develop adequate new standards, but at the same time also develop harmonized processes to implement or to use existing standards that support interoperability, and whether that can be done in a sufficiently short time frame and in an efficient way. And I think these are the key things. If this is not the case, then there is a clear role for public policy to foster the emergence of such standards to support interoperability, and especially the interoperability between devices and services that are provided by different market participants to the different customers. And this is really, when we go back to the overall objective, this is really key to facilitate the emergence of such new services and products that we urgently need in the energy sector to activate, for example, the demand side, to, in the longer run, promote also sector convergence, and hopefully in the end, at some point, to achieve decarbonization in a fast and also least cost way. And I think in this regard, when doing so, governments and also public authorities are well advised to look beyond the energy silo, and we have heard that already multiple times today, and to consider developments in other industries. And there are already examples in European countries, both member states, like was already mentioned by Bas in the Netherlands, but also non-member states like the UK, where there are government-backed or government-driven cross-sector working groups and cross-sector initiatives established specifically to exploit or to identify the potential for exploiting synergies between the sectors and also to avoid duplications and drive progress and be faster. So I think in summary, I would say that there is a role of public policy and also governance, and especially key is that when it's not very clear whether the markets and the competitive actors, also the industry, will be able to converge somehow or to develop standards and interoperable solutions by themselves efficiently and fast. Thank you.
All right, thank you very much, Valerie. We will, there are a few questions that have come in through the Q&A. Certainly I encourage other questions as we engage with the panel. And as well, the panelists may ask questions to their fellow panelists if they'd like, since all your mics will be live. The first thing I saw in the Q&A was more of a comment. I see Kale had responded as well, where one of the participants had said, hello, concerning standards, I would like to signal the following ongoing standards development, and then references the 23751 data sharing framework, which is ISO IEC JTC1. They mention a 27556 privacy preference management and the 27560 consent record information structure, also with JTC1. So it's not a specific question, it's just really a comment, but I didn't know if any of the panelists wanted to say anything about some of those works in progress.
I can only say that I was not aware of those initiatives, and if anyone knows any public draft versions of these, I would appreciate if you can share.
I'm not aware of this specific work. What I can say is that there is in IEC, there is a system committee, Smart Energy, which has been created several years ago to avoid to have silos of standardization inside IEC, and we have set up a joint working group at the system committee level with ISO GTC1. So maybe they will address this kind of use case, I would say.
What I would like to stress in this perspective is indeed to have the right use case. The use of the data is important and not focus only on standardizing something of data because you don't know how to use the data. So.
All right, let's go to the next question I see on here is, there are many types of more or less intelligent smart meters in Europe prepared for rollout currently. Some of them include options for data encryption, which is needed for secure data transfer, some not. Is there already a standard with minimum needs for communication security of smart meters?
Not aware of that.
Okay. All right. Well, so there is another question here. Garrett, since you're on, there's a question of, is there any initiative to unify EBICS and SIM?
Yes, there is. EBICS is trying to convert to SIM. That is all its models. So what we do is in the business requirement specifications, we drill down what we call business information models. These are mapped to the SIM information model. It needs adaptations in SIM, but work in progress there.
Yeah, it confirms that EBIX experts are participating in TC57 Working Group 16, which is developing SIM for market, the European style market profiles. Back to the previous question, I can speak about the security, cybersecurity standards for smart grid systems. So for instance, the 62351 series has been developed in TC57. Yeah, we need to figure out how these standards could be also shared with other TCs developing smart metering standards like in IEC TC13. But I don't have the final answer to this question.
I will add that there was a follow-on question from the same person about asking about whether there's any timeframes on that unifying initiative.
It started.
I don't have specific timeframes available.
All right. While we wait to see if there's any last questions before we conclude the panel, one question that I will bring up, having been involved with IEEE standardization for a very long time, as we all know, standards can take quite a bit of time. And do any of you see issues of the, I'll say, the time to market with some of the standards that we need in this space? Are there issues? Is it going to take too long, or do we think we can meet timeframes to meet overall goals?
It's a very good question. That also the objective in Europe.
Oh, Eric, your connection froze. I didn't know if anyone else wanted to jump in until we get Eric.
I can take over here, not knowing what Eric wanted to say, but I was inspired also by Valerie's presentation that
and to avoid silos.
Oh, Eric, you're back. So why don't we go have Eric speak and then Khaled.
Sorry, my connection is unstable. So I was mentioning that it's really important at the European level to have this kind of coordination between the European projects funded by the European Commission and standard organization, user groups. These European projects can experiment standards, find out new gaps, and so on. It's also important to have certification schemes. So we are also developing this, and SOE is already setting up its certification schemes for its developed standards like CGMES and ESMP, European Standard Market Profiles. So, but it's a very good question. We need to find the best way to accelerate standard development. And I would mention that it's really important now. Standards are what we call code components. Standards are not anymore document papers. You will buy a standard or you will use a standard, but you will also use a code, a piece of code. And it is really important to mention this. And IEC has set up all the process to develop these code components associated to the standard documents.
Thank you, Eric. Khaled, did you want to add to that?
Yeah, what I was starting to say before is that I think we need probably some kind of balance, especially if we want to reach quick results. So the balance between the, let's say, industry-driven standards on the one side, on the other side, what Valerie mentioned, on the maybe more like centrally government-pushed standardization initiatives, and maybe thirdly, also some even to go towards more standardization, more centralization, having some kind of platforms like Green Button, which really is maybe something between. It's a set of standards, but also it has some central components. So we probably need to have a balance there. And everything has to be equally on table to really achieve quick results. And I'm sure Georg Hartner will address this point in his last presentation as well.
I think we have time for one last question. And I see Eric already acknowledged he'd like to respond to it. It was a question on the need for more synergy between ISO and IEC concerning security and trustworthiness. Eric, did you want to take that?
No, I see that Antonio Kung from Trialog asked this statement, and he's mentioned that this, I would say, coordination between IEC and ISO can be endorsed by this joint working group, which has been recently created in the System Committee Smart Energy at the IEC level. So it's really good to have experts involved in these kind of standardization working groups. So we welcome experts because we need to have experts participating in these working groups. It's a way also to accelerate the standardization, the standard development.
All right, with that, I would like to thank all the panelists and appreciate your time and thoughts on this. And now I will turn it back to Georg as we move to our last presentation.
Thank you, Rudy. Thank you, Rudy. Thank you to all the panelists. We'll hand now quickly over to Georg Hartner, who's basically been the key player in the European draft law, which will detail how data interoperability should be done. So pleasure to hand over to you, Georg Hartner.
Thank you, Georg. Thanks a lot for the invitation to talk today. My name is Georg Hartner. I work for Austrian Energy, and I was nominated by GEOD, the voice of local energy distributors in Europe, to the editorial team for Smart Grids Task Force Expert Group 1 for data interoperability. Next slide, please. Okay, so I would like to talk about triggers for EU data interoperability, the work that we do in Smart Grids Task Force Expert Group 1, scope of consumption data access that we are dealing with, the design challenges for a consistent interoperability approach, and what we plan from a legislative point of view, and how the overall enterprise architecture for the interoperability effort that we are planning is structured. Next slide, please. So the main trigger, Clean Energy Package Directive EU 2019/944 on common rules for the internal market for electricity, demands in Article 20 the making available of validated historical consumption data and near real-time data directly from the meter. Next. Article 23, data management, demands a provision of rules for access to customer data by eligible parties. And with that data, they mean data required for like metering and consumption, demand response, billing, switching, and other processes. Next. We have Article 24, interoperability requirements. The Commission shall facilitate the full interoperability of energy services based upon national practices via implementing acts, which means that we're not meant to design some like European Google for energy data, and we need to be working upon existing national practices. Next slide. The work is mainly done for now by the Smart Grids Task Force Expert Group 1. Smart Grids Task Force was formed end of 2009 to provide expertise for the European Commission in their legislative work, provide reports, draft acts, and provide input. Currently, we are divided into three main groups. One is Expert Group 1 for data interoperability, which I will talk about today. Expert Group 2 for security, and Expert Group 3 for demand response or distributed flexibility. Next. In the past, Expert Group 1 has done the report My Energy Data to lay the ground for data sharing, define use cases for the sharing of validated historical consumption data. And the second report was done until 2019. It was called Towards Interoperability Within the EU for Electricity and Gas Data Access and Exchange. And that should lay the ground for these implementing acts. We formulated a number of crucial recommendations that now serve as design principles for the Interoperability Act that we are drafting. Next. So in the beginning of 2020, we began our multi-annual work to draft implementing acts and provide expertise to establish that interoperability. We began with defining an interoperability approach that would be viable for data sharing distributed flexibility, and other services. And at the same time, we began working on the provisions for data access and data sharing. We will try to conclude our work by the middle of 2021, and we see a probable adoption date in beginning of 2022. And after we have completed our work on data sharing and the general approach, it will go on with distributed flexibility and other services most likely. Next slide. So as we took data access as an example to draft the interoperability approach, we should talk about the scope of data sharing that we talk about exactly. As Article 20 demands, we need to establish interoperability for the access of near real-time data directly from the meter. So we've got the main meter on the one side. We left sub-meter data access out of scope for phase 1. And we're just talking about access through an in-house display interface, H1, to near real-time data by some sort of data consumer that is directly attached to the meter, not necessarily providing remote access. So near real-time data is one use case family. Here, the interoperability challenge is rather a technical one. Next. And then we have another use case group, which we validated historical consumption and generation data. Data flow is usually from the main meter to a role that we call a meter data collector, usually the DSO. Then a meter data responsible would validate and store the data, also usually the DSO. Then we have a meter data administrator role, whose responsibility is to make that data available. At the moment and before data sharing is mandated, to make it available to established actors like the supplier, regulators, and others. And we have countries where this role is being fulfilled by distribution system operators, by transmission system operators, or by dedicated entities. Now, as next, please. Article 22 also demands access to that data. We have created a use case, download my data, where a data access provider facilitates the access to that data by the customer. And next, as Article 23 demands the sharing with eligible parties, we have added 3 additional use cases. One being share my data, where a consent administrator facilitates data sharing between data that is stored at the meter data administrator and an eligible party through consent by the customer. Of course, that eligible party can terminate its service, so, other use case family, and then also, of course, the customer can revoke his consent. Next. It is important that we are trying to work along established lines of responsibility. That means that data transfer always comes from the meter data administrator still. Also to guarantee non-discrimination and make established actors use the same structures that also eligible parties can use. The remote way to access to data directly from the meter is not foreseen in our Act because it can easily be established through other means once the first interface, once the interface on the left-hand side is established. So we left it out of scope for now. Next. So to make these things interoperable or to provide sets of rules for this, we had some challenges to overcome. One is that we have a diverse, left, please. Okay, so the challenges that we were facing were a diversity of national data management architectures. So we have a number of countries that are utilizing national data hubs where data is copied to, and most energy-related processes are done on that hub. And we have decentralized environment, for example, in Estonia, Finland, Denmark, or Norway. And we have decentralized environments where data is rather kept at the source, at the DSO, and it's just exchanged within defined business processes. And we also, like in Austria, Germany, France, or Spain, and we also have hybrid scenarios. Then another challenge is the different implementation degree in member states. So some countries are acting as front runners, and we need to allow them to, to keep on making the pace. Whilst for the others that are probably still tying their shoelaces, we need to allow to cope up and to make use of the shortcuts that were probably found by these front runners. Then you cannot write everything into legal text, and you cannot write everything into technical standards. So we needed to find a balance here. And also comparability needs to be established in Europe. So at the moment, I think also as Simona said, it's very hard to know how to access data, even if you talk the same language. If you want to get to know about how data access is being organized in another country, it's a very hard thing. So we need to establish that comparability before we can go the next steps. And also we needed to find the right level of prescriptiveness. You can rather demand documentation of procedures, or you can demand sets of functionality. So here also we need to find a balance when we design the interoperability approach. Next slide. So what did we use as pillars? One thing is the Smart Grids Architecture model by Sensanelec and Etsy, 2012. It's a 3D reference model to describe interoperability challenges and different settings, different use cases. Very useful. It's set into domains, zones, and interoperability layers from component or device level to communication level to information level, a function layer for system use cases, and on top a business layer for business objectives, regulatory frameworks, and everything. So we worked a lot with that. We are working a lot with it, and it's very useful. Next, we use European role models like the harmonized electricity and gas market role models, IEEE My Energy Data terminology, and also legal terminology. The good thing with these harmonized role models is that they abstract national actors and rather describe sets of responsibilities for certain players in a use case. So a harmonized electricity market role model would define a meter data administrator at the European level, but they don't say anything about which national player fulfills that role in a member state. So in one member state, it can still be the distribution system operator. In one, it can be the TSO, and in another one, it can be a different actor. Next. Then we are using a big interoperability toolkit. So the IEC SIM, the previous work of EG1, IEC 62559 use case methodology, sister initiatives like the European data spaces, and also eIDAS and electronic IDs. One big challenge is the authentication of eligible party that are coming from another member states. As Simone already pointed out, in some countries to register for market communication, you need to have a national VAT, which can be a big hurdle and EIDAS and electronic IDs is a European way to non-discriminatorily authenticate legal and natural persons. So that would be very helpful, but not yet ready to be woven into the general initiative. Then, of course, the General Data Protection Regulation and other initiatives. Next. And probably the most important thing in our work is the stakeholder input. We are writing legislation for a big number of countries. We need the input from customer representatives, regulators, commission, very importantly, ESCOs or eligible parties, DSOs, TSOs, governments, standards development organizations, meter vendors, and others. Next. So what are we planning to do? We have a legislative effort. It started with the primary legislation, clean energy package, done by the EU Parliament and the Council, very high level. Then we have the implementing acts. More detail is possible here, but they are very hard to adapt. So we identified the need to appoint some responsibilities to an EU competent authority for the ongoing work that requires flexibility, step-by-step approaches, and so forth. It's not yet decided which player will be the EU competent authority. It can be the EU DSO, it can be N2E, it can be another player probably. Next. And what we do in these implementing acts is they will contain what we call reference model, which is used to describe the similarities and differences between member states in an understandable way. These reference models will contain a process model, which describes process steps as information exchange between the roles in the role model, using information objects and attributes in the information model, and the information model will just contain semantics for now and doesn't say anything about data formats or syntax for now. Next. So we see the role model and the information model as a general thing that should be shared between the implementing acts, and each so we will most probably have a general implementing act, and then another act for data sharing, another act for demand response, another act for other processes, and they will contain a process model that refers to the roles and the information model that are rather general. Not 100% sure yet, can also be that each of these acts will have their separated role and information models. Next. And if we have the implementing act ready, these reference models will be handed over to the EU competent authority, who will provide guidelines and templates for the mapping of national practices. They will then be handed over to the member state authorities, who will map the national practices towards that reference model, report them back to the EU competent authority, who will then do quality assurance and conformity assessments and make these mappings available at this single point of reference, European single point of reference, with the goal to close the information gap, to make to answer Simone's questions, like we don't know how to access data and we don't know how to talk to. So to solve these issues, and once these things are easily available, we see the possibility to tackle next the full technical interoperability, which we see an option in creating technical reference models like OpenESPI, for example, like the SIM, and technical mappings of member state environments of different meter model interfaces towards that technical reference model, and that would close the gap for the full technical interoperability. Next. So thank you for your attention. Of course, it can just be an overview in these 20 minutes. We hope that the work that we do here is just the end of a beginning. So the establishment of EU-wide data access can just like unlock things, but the benefits really need to be realized by others. For example, like Simone, and we should have a focus on making their lives easier. And this will still take some time. As I've said before, we really need your feedback. There will be an open consultation, public consultation for the implementing acts, but I would also be happy to get to know more about your opinions and your input and probably your ideas. Thank you.
Thank you, Georg, for an excellent presentation. I would ask one question from you. You had in one slide a probable implementation in 2022. When will you have EU-wide access for data in Europe? When will member states have implemented the implementing act?
Okay, when of course that's the other end of the beginning, I would say. So after this has been locked in, after we have closed the information gap, there must be another or maybe some initiatives to create probably a unified European interface, to probably allow for open source initiatives, to provide a solution to that technical interoperability problem. I think we will see centralized approaches, we will probably see decentralized approaches, but there needs to be something in between after the work that we're doing implementing act, I'd say.
Thank you very much. We are nearing the end now, as I do not see further questions in the Q&A. Besides, there's a thank you to Georg in the Q&A. So thanks, thank you so much for a good overview, and best of luck to the implementation. We are now drawing the webinar to the close. So it has been a wonderful whirlwind tour. I think what we all agree on is the value of data access and the importance of the work. And we've seen many initiatives from both sides of the Atlantic about how to solve it, as well as many learnings of what to do and what not to do. Perhaps my personal takeaways from this is not to reinvent the wheel, to use what's out there, to openly involve all stakeholders, and to keep the focus on people and ease of use. I think with those learnings, we can make a EU-wide and in the future global data sharing ecosystem possible, so that innovators can cross geographical boundaries and provide value around the world. So thank you, Rudy. Would you like to say some closing words as well?
Yeah, just quickly, thank you very much to Georg and Kalle from Ellering. We've been working a lot in the past months to pull this together. A very big thank you to all our speakers, for your time and all the information you were able to share with the group today. And certainly thank you to all the attendees who participated. There were a few questions on making the presentation available. We do intend to make that available through the IEEE website. I can't tell you exactly when, but it should be available fairly quickly, hopefully within a week or so. But we will let everyone know when that becomes available for those who'd like to take a second look at things, as well as for additional people who weren't able to join us today. But other than that, and also a big thank you to our behind the scenes, to Christina and Victoria for doing all the magic behind the scenes to pull this off. So we appreciate it.